Good morning. So today we will finish up chapter 4 with section 4.4, solving logs and exponential equations. Solving logs and exponential equations. Now this is very critical because this is the area where students have often had issues over the years in the past. So in solving an exponential, so an exponential equation, first of all, is one that has the expression, the unknown that you are trying to solve in the exponent. For instance, I can say 3 to the, for instance, 3 to the power x plus 5 equals to 2 is an example of an exponential equation. All right. So the question is to solve for x, and the x is in the exponent of some exponential term or exponential expression. All right. So the issue here is to remove the x expression from the exponent and bring it down somehow without changing the question. All right, before you can be able to solve. You cannot solve for x while x is in the exponent of this term, this expression here. You can't solve for x while x is in that exponent. So the issue is to try to bring the x down without changing the question. All right, so this is now where the log functions then come in. So I told you that it's a very nice thing that logs and exponentials are inverses of each other because they kind of help each other in this kind of instance. All right, so we already saw that if b, if the log of x base b is equal to y, then it is the same thing as saying that b to the y is equal to x. All right. So our what we intend to do, our intention is to rewrite this exponential expression as an equivalent log expression in which our our exponent, which is what contains the variable we are trying to solve, is no longer in the exponent. All right, in which that expression there that contains our x is no longer in the exponent. All right, so every exponential equation you will ever get to solve will be in any one of the following two forms, either in this form or in this form. All right, so it will either be given to you in the form b to the y is equal to x. All right, and then in order for you to solve for y is in the exponent and you want to solve for it, so then you translate it into an equivalent log, all right, which is the same as saying that y is equal to log x base b. All right, so you have now removed y from the exponent of the b without changing the question. All right, once you do this removal, you can then proceed with solving for y using any of the methods that we have seen in chapter 0 and 1 for solving equations. Okay, so alternatively, the question can come to you in the form a to the x equals a to the y. For instance, say 2 to the x plus 1 equals 2 to the 3 plus x. All right, then since the bases are the same, you then just equate their powers and solve. All right, since the bases are the same, you can then just equate their powers and solve by saying x plus 1 is equal to 3 plus x. All right, so this then becomes a linear equation which we all know, we've all seen how to solve. So the end thing there is to try to remove your expression which contains your variable, remove it from the exponent, and then you can be able to solve. Right, so you get this better when we start looking at a few examples. Okay, let us look at a few examples first of all before we move over to logarithmic equations. Before we move over to seeing how to do the log equations, let us look at a few examples on solving the exponentials. Okay, so look at this example, for instance. It says solve for x in the following. So 3 to the x plus 5 is equal to 1. All right, so I want to solve for x, but x is in the exponent. All right, so the first things first when you get this kind of thing is to check how does it look like. Does it look like my case 1 or does it look like my case 2? Right, my case 1 was the case where we have my case 1. Let me just write this out nicely. So case 1 was where we have b to the y equals x is given to you, and then you change it to the equivalent log of log base b of x is equal to y. Case 2 is where we have two functions with the same base. All right, then you just say that therefore their powers or exponents are the same. This was my case 1. I told you that you can get logs and exponential equations in any one of the two forms, either in this form, then you change it to this form and solve, or it's given to you in this form, then you change it to this form and you solve. So looking at this question, for instance, it is in this first form. All right, a base to the power equals a constant. It's in this first form. So then I change it to, so this is equivalent to saying therefore, so if 3 to the x plus 5 equals 1, therefore log to the base 3, okay, remember the bases don't usually change. Log to the base 3 of 1 is then going to be equal to what? X plus 5. All right, and we already know from one of our laws of logs that log 1 is 0 despite the base. Log 1 is always 0. So that's to tell me that x plus 5 is equal to 0, and this is then a linear equation which is easy to solve. So therefore x is equal to -5, and that is your solution. All right, now what if your question is given to you in the other form? Let's say 3 to the x plus 5 is equal to 2 to the, or 3 to the 2x plus 1. All right, then this method says that if you are given this exponential equation with exponents of the same base, then you just equate their powers and you solve. That is how you remove your expression from the exponent, your desired expression. So 3 base 3 equals base 3. That tells me x plus 5 should then be equal to 2x plus 1. All right, then this is a linear equation. You can collect like terms together and solve. So if we move the x's to this side, we have a negative x is equal to, move the 5 to that side, -4. All right, so that x is equal to 4, and that is my answer. Okay, and that is my answer. So these are the only two ways. So sometimes it could be twisted and not given to you directly in this form. All right, for instance, we could get 3 to the x plus 2 minus 3 to the x is equal to 1, for instance. All right, then if you look at this, you see that it's not in any of these two forms, form 1 or form 2 here. It's not in any of these two forms. All right, so what do? You try to make it be in any one of those forms. And as I'm looking at this now, I see that it is easier for me to you try to make it look like any of these two forms. Okay, I would rather have 0 there than 1. So these are not properly set questions. I'm just trying to make them. So so it's there. So then the only thing I need to do then is to move one of them to the other side. So I have my 3 to the x plus 2 is then equal to 3 to the x. All right. So that I can then have it in my form 2. Okay, it's then in this form, and I can then go ahead to equate x plus 2 equals to x, and then I solve, right? So you can see that it's kind of not solvable. As I said, these are not properly set questions. These are just so 2 is equal to x. X is 2, and that is my answer. Okay, so if it's not exactly given to you in that form, you have to make it be in that form for you to solve. So we will see more of these solvings in your tutorial. Okay, now let's move over to looking at the log equations. Let's look at the log equations now. So looking at the log equations similarly, okay, equations in which the unknown is the log of a certain expression, all right? The unknown is in the argument of the log. The unknown is in the argument of the log. For instance, log of 2x plus 5 equals to 3, and you are asked to solve for x, all right, in log 2x plus 5 equals 3, and you need to solve for x, then you will see that the expression in x is in the argument of the log. There is no how you can solve for x except you separate the log from the 2x plus 5, right, without changing the equation. Okay, so that is where these formulas and the laws of logs and exponents then come in to help you change this thing without necessarily changing your question. Okay, so similarly, just like the exponentials, the log functions will always come to you in any of the following two forms, all right? So it will either come to you in this form, all right, wherein you then change it to the exponential form so that you remove the log, okay? Or it will come to you as two logs of the same base being equal so that you can equate their arguments and solve, just almost the same thing as we saw with the exponents, okay? About the same thing as we saw with the exponents. Now let's look at a few examples. Let's look at a few examples on how to solve this thing. So this question says log 9 base x is equal to 2. Log 9 base x is equal to 2. All right. So in what form is it? If you look at it carefully, you will see that it's in form 1. This first form, it's in this first form. All right. Log of some argument is equal to a constant in this form. So we now change it to this form, all right, and then we solve so that we separate the log from the expression containing our variable. So changing it to that form is saying this is the same as saying that x to the power 2 is equal to 9, all right? So then, which means that x squared minus 9 is equal to 0. And this then is a quadratic equation which we all know how to solve either by factoring or by using the quadratic formula, right? So this is x minus 3. It's a difference of squares. Difference of squares, x plus 3, all right, equals to 0. Okay. And so x minus 3, x plus 3 equals 0, so that we then have our x to be 3, or x to be -3, and that's that. All right. So the main thing is to be able to identify in which of the two forms the log or the exponential equation is given to you. Once you identify that, you convert it to its corresponding form, all right, which will enable you remove the log or the exponent, separating it from the expression containing your variable. Then you can identify whether you get a linear equation in the process, or you get a literal equation in the process, or you get a quadratic equation in the process, and you use the corresponding method of solving that kind of equation to solve for your variables. Okay, now let's look at this other example. Says solve for x where log of x base 16, log 4 base 16 is x. So this one is already given to you. So your x is just equal to log of 4 base 16. Okay, your x is just equals to log 4 base 16, or 2 log 2 base 16. Then the next one says log of 4 base x is 2. So again, this means, so this is in the first form. So in the first form, we translate it to its corresponding form, which is x squared is equal to 4, right? Again, it's a quadratic, easy to solve. X squared minus 4 equals to 0. So x minus 2 times x plus 2 is equal to 0. And we get our values as x is 2 or x is -2. Okay, and that's that. Then this other question says that use the laws of logs to expand as far as possible. Now, I don't want to do expansion. You can do that at your own time while you are studying. Those ones are easy. I want to look at the equations and solve the equations. All right, so this one is a nice one. This one says solve for x here. Now, this equation, you can see that clearly it neither looks like the first form nor the second form. All right, it neither looks like form 1 of the two forms that you can get, or form 2. So, but what you do is you make it look like one of them. And as I'm looking at it, it is easier to make it look like form 1. Okay, you can still make it look like form 2 anyways. All right, so let's try to make it look like form 1. So first of all, form 1 contains only one log. So form 1 is of the form log of x base b is equal to y. That's the form. One log on the left hand side and a constant on the right hand side. All right, that's what. So, but then this log has two logs on the left hand side and a constant on the right hand side. So I need to make it one log on the left hand side and a constant on the right hand side for it to look like form 1. And then I can be able to then apply the corresponding exponential form of form 1 and solve. All right, so how do I do that? This is where my law of logs, law 1, comes in. Law 1 says if I'm adding two logs of the same base, I can multiply them and make them one log. All right, so this thing just becomes the log by law 1, laws of logs. All right, law, so it becomes x minus 2 times x minus 3 base 2 equals to 1. Okay, so this looks to me then now like this form, okay, of the equation. One log on the left hand side, a constant on the right hand side. So correspondingly, it says that if I have this form, then it simply means that b to the y is equal to x, right? So therefore, 2 to the power 1 is equal to x minus 2 times x minus 3. Okay, so you can then expand, all right, multiply out the brackets, expand and multiply out the brackets, collect all the terms together, you will end up with a quadratic equation in x, which you will now solve using any of the methods of solving quadratic equations and get your x values. Okay, so that is basically how we do this stuff. So you must always, so every time the thing is not given to you in any one of the two forms, okay, when I say form, I'm referring to any one of the two forms in which we can get a log or an exponential equation. So for the logs, these are the two forms, this one and this one. All right. So if it's not given to you in any one of these two forms, then use your laws of logs and exponents to translate it to any one of those two forms and then we solve. Okay. So otherwise, you can just get it straight away. All right. So that's that about this. So you'll see more of the solvings in your Okay, so you'll see more of this in your tutorials, and if you do not get anything, you can just book a consultation for more explanations. Thank you.